Okay.
Sir, I have removed. Sir, please try
Okay.
again.
Okay. 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 Just wait. Okay, so I am audible and my screen is visible to all of you. Mintu,
Yes, sir, you are audible, but your skin is,
I think it is coming.
yeah.
Just wait. Okay, once it is coming, without wasting time, because there is the scheduled time is there, so I don't want to waste that time.
Sir, please
And
make the
again,
screen full screens. Yes, now it is coming. Okay.
yes, yes, it is coming. Again, good morning to all the participants and the organizing committee of that 5-day STTP program on recent trends in sustainable development, which is organized by the Department of Basic Science and Core Engineering, Bengal College of Engineering and Technology, Durgapur, which will be going on from 9th December to the 13th December 2025. Today that I am going to present that session, real-time applications of parallel manipulator, that is called basically the Stuart platform. That is how it will be related to the sustainable development program, what you have the program, and what is the real-time application and the real-time situation, what we have to adopt that particular things, because of the all the industry, it is going to the automation basically. So we should know at least the few idea of the robot manipulator, that type of things. So before going to my particular things, that is the parallel manipulator, I should concentrate on the particularly a few things, the brief idea, the basic conceptual knowledge we should have, the what is robotics, how the classifications will be there, because I have heard that the maximum participants of that particular program, the students are there, few faculties are there, maybe they have the idea, but students, they should know the basic idea of the manipulator, better to say what is the robot, what is the classifications are there. So now I am going to my that slides, what is the actual topics will be covered throughout the total presentations. So that second slide is visible, Mintu. So please share, please confirm so that I can proceed.
Yes, sir, it is coming. You could proceed.
Okay, okay, okay. So I will continue. So this is the contents of the total presentation. Basically, the three parts, subparts are there. Few common queries related to the robot. What is actual robot? What we should have the idea, basic idea. Then second part is the classifications of the robot. What are the different examples are there? What are the different applications are there? Then I'll shift to the my particular part. This is the parallel robot manipulator, which is better to say the Stuart platform. Now, again, that part has been classified. What is robot? What is the sustainability? That means how it is related to our STTP program. Then what is the difference between human and robot? That means what is, once we have to know the robot, what idea we should have in our mind. Now, what is the definition of the robot? How it is related to the sustainability? What is the difference between human and that manipulator, or better to say the robot? Can robot replace the human beings? That question will comes in our mind. Then what is the difference between robot and machine? And last part, we have to know few in a simple sentence, simple words, what is the basic definition of the robot. Now comes to know what is robot. Now, if you see my slide, there are few images are there. Some it is a machine which is like a human being that can do some work what we are doing, but difference is there. It can do the repetitive work without any, without what is the feelings in our mind when the repetitive work will be done. After some time the precision level will be less, but in case of the robots, it can do the repetitive work without the failure of the chance of the precision level. So this is the main difference, because once I have, suppose I have the schedule time from say, let's say 10:30 to 12:30, but if organizing committee will ask me to give the lecture throughout the day, throughout the 5 days, after one lecture or two lecture, the quality of the lecture will be very less compared to the first lecture, because that monotonous work, that repetitive work cannot be done by the human beings. That's why if you follow the class routine in your any semester, you can follow, one faculty member cannot be assigned 2 class consecutively or 3 class consecutively, because of after 1 or 2 class, maybe in the third class, he or she has some that monotonous activity will be there, or that repetitive work cannot be done, but it can be done by the robot. So this is the main difference, this is the main definition how you can distinguish the robot and the human beings. So try to understand that things at first from that particular slide. Maybe there are few sentences are written, but just things is, this is the main difference in your robot and the human beings. Now comes to the next slide, which is related to our STTP program. What you have, the sustainability. Sustainability means that development. Suppose you have to build up one industry in an area, because you guys are coming from the Durgapur. Durgapur is very developed city, and there the industries are there. So suppose another industry has to be developed in a particular place where some trees are there. So you have to cut the trees and you have to build the industry. Now you think that whether that development will be sustainable, yes or no. One thing you have to think, I am developing the industry, that is fine, but at the same time you are decreasing the level of the oxygen, and that basically you are cutting some trees and you are cutting some forest. So what you have to do, you have to develop the industry. Parallelly, you have to cultivate some trees in the another place, or maybe the surrounding of your industry there are some trees should be there, so that that development will be sustainable. This is one very simple example. The common people can understand how the development can be sustainable development, because we have to develop that in a way our future generation, they should not be suffered. So this is the sustainability. Now comes to the point how the sustainability is related to the robotics point of view, because my topics is robotics and your STTP is the sustainability. So that should be related, that should be connected. How it will be related? Now comes to the point, from the environmental sustainability point of view, if one point I can say, the resource efficiency. What is the resource efficiency? Now, robot can optimize the energy or material which is used in the manufacturing. What is that thing? Now, suppose if one human being is employed in a particular manufacturing industry, he or she has not enough idea how to optimize that material or some energy. but some robot or some some manipulator which has been initially given some command how much energy or how much material should be used for that particular manufacturing industry, so that will be optimized basically. So this is, you can say, one point of sustainability, because for that particular production process, say let's say 1 kg material, raw material should be used, but if any person will be used, then he or she can use some more than or some less than. If less than, that will not produce the quality manufacturing. If it will be higher material, then also the quality point of view, it can be decreased. But another point will be also, it will decrease the sustainability point of view. So that resource efficiency, one major point from the environmental sustainability point of view, which is related to the robotics. The other points also there, some agricultural points. Now the drones are used to spray the medicine in the field, the cultivation field. If one human being is used, human beings is employed, he can spray the medicine in a same place 1 or 2 times maybe, but some drones are used now. So drones, it will spray the medicine very optimizedly, and that will be your environmental sustainable point of view. The other points are there, you just go through the renewable energy, hazardous task, waste management, some points are there. So this is the related how robot can also give the sustainability, that environmental sustainability also. So now comes to the another sustainability point of view, our robotics, social sustainability. What is the social sustainability? Now, improved working condition. Working condition means what I have told initially, the difference between the robotics point of view and human points of view. The repetitive work can be done by robotics. So that is one improved working condition. As it will improve the working condition, it is the sustainable point of view. Which type of sustainable? The social sustainable point of view. Another point, upskilling. Upskilling means automation has come now in the industry. So that automation points, this is related to the upskilling. That upskilling related to the social sustainability, and that social sustainability is related to the sustainable point of view. So again, I am saying that robotics application in industry, in manufacturing, that will improves the sustainable point of view. Another point, that is the challenges and future direction. What is that thing? Now, that research focus is coming with the recyclable, self-healing of robot materials. That recycle means, if now that you can say, you can see the government, our India government is taking the initiative that you use that plastic which can be recycled, that micron level is very less. So in case of your robotics point of view, that materials which will be used, that should be recycled. So that is one point of your sustainable point is there. So two slides, the previous slide and that slide, basically that is related to the sustainability point of view, which is related to our STTP program, and that is my topics, that is the related to the robotics also. Now comes to the what is difference between human and robot. Already few points I have covered. Again, I am sharing few another points. That means, say, it can, the sensing point is very high for the robotics, and perfect work can be done. It can do the repetitive work, monotonous work. Now another point is there, three area where human cannot do, human can do but robot cannot do. What are the 3 points? Now, empathy. Empathy, that is the ability to understand the share of the feelings. Suppose I have some feelings, that can understand the other person who is sitting around me. But it cannot be possible for the robots. But maybe you can raise the question, sir, now the some robots are there which can feel the empathy. That is very rare case, and that is coming in the future. In the future, research is there, but it is not very easy to give that type of program which can sense your that can have the ability to understand the feelings what is inside in your mind basically. So that cannot be done. Another points are there: acceptability, trust, flexibility. So these can be done by human beings but cannot be by the robots. So this is the difference also, that merits and demerits what we have studied in the other case, that is also demerits in case of our robots. Okay, now comes to that few application points of view, because I have told initially what is robot, then we have some idea why, where the huge area where we are using that robotic applications are there. Now question is there, can robot replace the human beings? You can give the answer, yes, you can replace the robot by, you can replace the human beings with the robot. How? If you see the figures here, in case of farming, you can see in your around where the cultivation fields are there. Now you can see there the farming field also, in the farming field also robotic applications are there for the cultivation. When it will be cutting the that cultivation field also, there are some robotic applications are there. In the automobile industry also, in the packaging, that the robotic applications are there. So human can be replaced by the robots. That answer can be, you can say as the yes, because the huge applications are there. In the case of your welding purpose also, that means one huge application in the manufacturing industry. There also, if you see the left hand side, one human beings is doing the welding. Suppose he is doing for the 5 hours to take 6 hour, 8 hours. After 8 hours, when it will be 10 to 12 hours working will be there, that repetitive work, monotonous works will be there. So precision level will be very less. But in case of the robot, it can do the repetitive work and monotonous work for a long time. Okay. So these are the difference basically. Now that you can see the another applications also, the automatically that operated machine which can be used for the construction purpose for a long building. Suppose some labor I have to employ, maybe say 10 or 20 labors are there, and it can take say 5 or 10 days for the say construction purpose. But if you see the figures here, it can do within a 1 day. So once that type of work will has to be done with a very less time, and that precision levels will be high. Maybe the initial cost for that type of machines is high, but it can do with very fast work. Now, so up to this slide, what we have the idea. Now, what is actual the definition of the robot? What is difference between human beings and robot? What are the different application fields are there? And the one question, whether we can replace the human beings with the robot. Now comes that point, what are the different classification of the robots, and one few example and different applications. Now comes that different type of robot, their example, industrial application, their advantage and disadvantage. There the all the figures are there, and the details are in the next slides are there. So so if you see, this is the articulated robot, this is linear robot, this is your gantry robot, this is the cylindrical, this is the SCARA, this is the parallel robot. Now if the participants has some idea, if you come this slide, what is that linear or Cartesian, or it can be say gantry robot. Cartesian robot means, what is the term, the Cartesian? Now it has three principal axes, linear axis basically, x, y, z. Okay, and these are in the right angle. That means x, y, z, three axes are there. If you see the figure, this is the linear robot. That means it can move in this direction. So application, what is the application? Now for the ceiling purpose, say for handling heavy loads, what is the advantage of that your linear robot? Now it is very highly accurate and its speed is very high, and that cost is less, and operation is very simple. What is the disadvantage? Now it will take large volume of space. That means to operate, to handle this particular robot, that means Cartesian or linear or gantry. Why I am saying three terms? Because be careful, particularly for the students who are the participants of that particular session. You may be sometime confused. Some in different books, different place, that names can be different. Cartesian, linear, and gantry, all are same. So don't confuse Cartesian, linear, gantry. These are basically, that will be when that the three linear axes of the controls are there. That means only x, y, z, and it will, one disadvantage, it will require the large volume of the space. Now this is the cylindrical robot. Cylindrical robot, if you see the figure, that is that workspace, this will cover the cylindrical. That means one movement is the this direction, vertical direction. Another, if you see that direction, that means this is your vertical, and this is called as the reach point, and it can have some rotation will be there. So what is the cylindrical robot? The two orthogonal sides. Sir, what are the two orthogonal sides? One is your vertical and one is, this is the reach point, and another is the rotary movement. What is the rotary movement? The base point that can move. So if two is the vertical, one is vertical and reach, that means orthogonal side, another is rotational. Combining three movement, it will give your cylindrical movement basically. That's why it is called as cylindrical robot. Otherwise there is no other reason why it is called as cylindrical, because it is working that total space that will cover as a cylinder. One is vertical, and it has some advantage, some disadvantage are there. I'm not going through, because these slides are there, you can go through. And then another part is SCARA robot. SCARA robot, if you see the figure, there is one joint 1, another joint is joint 2, another joint 3, and this is the end effector where you have to do the operation basically. This is the end effector. This is, you can say, joint 4. So here basically the xy axis and rigid in the z axis. So this is the xy and another is the z axis is there, and each and every joint basically, these are the robotic arm is there. And if you see that this is called as the SCARA. What is SCARA? What is the full form? The selective compliance assembly robot arm. Assembly robot arm. There are few arms are there. Just like we have right hand and left hand arm, two arms are there. Na? There are few parts are there basically. Few joints are there. Shoulder, elbow, few joints are there. Just like this is the some assembly basically. Selective compliance assembly robot arm, full form of the SCARA robot. What is the application? The assembly purpose, packaging, some loading purpose. What is the advantage? Now it has the capability of the high speed capability, and it is fast assembly. It can do the assembly work very fast. Few disadvantages also there. What are the disadvantages? Now it will be required the dedicated controller. Dedicated controller means it will be required to move the joint 1, joint 2, joint 3, different commands should be given for the joint 1 to joint n. So the prerequisite knowledge of the controller should be required to control, to move, to operate that type of particular robot. This can be one disadvantage point of view. But if you have the enough knowledge, there will not be any problem. Another name, that is the articulated robot. I hope maximum guys that you have seen that type of robot that is used for the welding robot, and say this is for the metal casting purpose, that is used for the packaging purpose, that can be used. This is very flexible. That is the advantage, is that articulated robot is very flexible and multi-application capability it has. But it has also some disadvantage. What is the disadvantage? The speed of this robot, the speed is very less. But if you see the previous slides, Kara robot, that high speed capability, but in case of the articulated robot, it has the advantage multi-application, but disadvantage is the speed is very less. So you remember this point of view. Now comes to the another part. This is the parallel robot. What actually I have selected to give the lecture on that particular STTP. Before going to that particular things, I have given whatever the slides before when it comes to that slide. These are the basic parts of the robots, that what is the definition, applications, examples, what are the classifications, and with the some example and advantage and disadvantage. Now comes to the another type of robot, which is the parallel robot. Before coming to that that total idea, what is the parallel? There is the series and parallel to what's are there basically. If you see, suppose before coming to that point, we have the two hands now. When you are doing some work with one hands, that work that you can consider your hand as a manipulator. Manipulator means which can manipulate, just like driver, who will drive, who drives the car, who drives something, who is called as the driver, he is called as the teacher. Just like your manipulator, which can manipulate, just like our hand also one manipulator, because I pick some object from a particular point, and by picking up this object, I am replacing this object to another place. So I have manipulated. I have changing the position of this particular things. So my hand is the manipulator. Now question is there, when I am doing some work with a one hand, that is the series manipulator. If I do some work with my two hands combining at the same time, that is not a serial manipulator. At that time, that will be the parallel manipulator. Just like if you see in my slides, say more than one manipulator or more than one, say, actuator, when it will be combining to do some work at a same time, that is called as parallel manipulator. So what is the advantage and disadvantage of the serial manipulator and parallel manipulator? Now, in case of your serial manipulator, suppose in your hand, if you follow up with your any one hand, right or left, workplace is more in case of the serial manipulator compared to the parallel manipulator. Workplace. But if you comes to the parallel manipulator, workplace will be less, because if you do some work with the two hands, you can follow, your workplace will be less compared to your serial manipulator or compared to your one single hand. But in case of the parallel manipulator, it can negotiate the more load. This is the advantage. Okay, so this is the idea of the parallel manipulator and its advantage and disadvantage. Now comes to different type of that what we have already discussed in a single slide. I have given in a single side you have some looks. Say this is the articulated, cylindrical, Skara, Cartesian and parallel manipulator. Now comes to that parallel manipulator, what we will discuss here. Now how that modeling is done, how it can be, motion dynamics can be done, what is the kinematics, their simulation work, experimental works has been done with our some real-time experiments. So theoretical discussion, what is simulator? Now which can some simulate that different type of simulator. That simulator, that means that what I can say, that suppose so one pilot has been given some training before going to the real-time applications. He or she should be given some training. How it can be done? Now, he or she has some idea before going to the real-time application. He has some idea with related to some replica of that type of things. He has some idea with how to operate that real-time application before going to that things. What he or she will do with this particular replica, that is actually simulator. If I go to that slide, you have the idea what is the simulator basically. This is the motion simulator. Say here the pilot will be placed, he or she will sit here, and in the below of that platform that your motions will be generated, and pilot is sitting there. He or she has some idea how to control in the real-time situation. So this is called as basically motion simulator. Okay. Now comes to the some motion cinema also, that I hope 4D cinema, 3D cinema, you have the idea. You are sitting in the cinema hall, but you have the feelings just like we are navigating, we are flying in some another place. So this is your motion cinema, which is basically related to some simulator purpose also. Earthquake simulator, it is used for the before going to the earthquake resistive building, that earthquake simulator is used. These are the another application you can see, that is the some tracking camera, tracking antenna, where that type of simulator is used to get that particular motion when it will be required. Suppose in a 15-degree motion of that particular antenna will be required. So it will, how it will be generated, how it will be given. Now in backside there the simulator is there the parallel manipulator is sitting, manipulator has been established so that it can give that type of motion. Say this is the missile launcher, this here also, that's your parallel manipulator, or better to say it is called as Stuart platform, because of that Stuart, he has developed, he has given that idea of the parallel manipulator. That's why that parallel manipulator also sometimes it is called as your Stuart platform also. This is also one application, ship simulator. Now comes to that real-time applications. What I have few experience to do the real-time experimental work with the hydraulic and electric actuators. In the initially I'll discuss with the hydraulic manipulator, then I'll shift to the electric manipulator. So if you see this slide very carefully, parallel and serial manipulator. In the left hand side, if you see, this is the serial 6 degree of freedom, and the right hand side, this is the parallel 6 degree of freedom motion. Both machine can give the 6 degree of freedom. DOF means degree of freedom motion. But question is there, the first figure, where if you see each and every part, that means this is 1, 2, 3, 4, 5, 6. This is your one x-axis, this is the y-axis, this is z-axis motion. Another, this is your along your x-axis, that is the roll, this is pitch, and this is yaw. What I am saying, Along the x-axis, this motion is called as surge motion. Along the y-axis, this motion is called as sway, and this is the hip motion. These three motions are linear motion. Another three motions are rotational motion. This is the rotational roll motion. Your rotational around the x-axis. Along the your y-axis, this is the pitch, and this is your yaw motion along the z-axis. So 6 motions can be done by that particular by particular geometrical shapes. But this is very high cost because of your there will be the problem of orthogonality problem, accuracy problem. One axis mounted over another. So once you do the manufacturing, once the fabrication, once you are designing, that problems will be coming. Accuracy problem will come. Okay, some errors will be coming. But in case of the parallel manipulator, suppose if we put 6 actuators, it can be, you can ask me, sir, it can be done with 3 actuators. Yes, it can be done with 3 actuators. It can be done with 6 actuators. But sir, what is the difference? Now, once you have to negotiate more load, you have to put the your more actuators. 6 actuator can negotiate the more load with compared to the 3 actuators also. Other reasons are there. I'll coming to the next slide. So this is the difference of the serial and parallel manipulator. You can go through that slide. Okay. Now comes to the other slide where the 6 degree of motion simulator. What I have told that surge, sway, hip. Here the difference points have been given. Surge, sway, hip, and roll, pitch, yaw. All figures are given here. So configuration, what is that things? Now this is the 6-6 configuration. 6 actuators are there, 6 bottom point, 6 top points. So 6-6 configuration. Other configuration, if you see, according to the bottom point and top point, that configuration names are there. Just like 6-3 configuration, 6 bottom point, 3 top point, maybe 3-3 configuration, 3 bottom point, 3 top point. So this is the 3-3 configuration. Okay. Now comes to that actuator. Sir, what you have told the actuator? Which part is the actuator? Now, if you see that figure, this is the bottom platform. This is the top platform, which is basically the moving platform. That's why it is mentioned as M. That can move, but fixed. That bottom platform. This is the F is written because this is the fixed. So these are the actuator. What is C? Now these are the cylinders, and P are the bottom point, and your T are the respective top points are there. So if you see here, 3-3 configuration, basically 3 bottom point, 3 top points are there. Now these are the cylinder. If you see that rod, this is the basically piston rod. So question will be coming, that actuator, why this is actuator? Now which can actuate something? Which part will be actuated? Now that within the cylinder, that piston rods are there. Piston rod can move to and fro direction. So that is why it is called as actuator. Now you can ask me, sir, that actuator can be hydraulic, that can be pneumatic, that can be electric. Hydraulic means which will be operated by some hydraulic, that means some fluids. That operations, that actuations can be done some fluids, or it may be some liquids or some airs. So when it will be some liquid, it is called as electrohydraulic, and when it will be some air, this is the pneumatic actuator. And when it will be electric, when it will be electric actuator, it will be with the electric actuator. So question is there, sir, suppose I will be selected as an engineer in a particular industry where my manager has asked, you have to choose that actuator whether it will be hydraulic or electric or pneumatic. Now you have to think out what type of operations are there. Just like before before going to that lecture, I have asked to the organizing committee, but better to say Mintu. I have asked to Mintu that who are the maximum participants are there, because I have to think out who are the listener of my particular lecture. If there are all the faculties are there, I should not go through the basic parts because they well known that parts that should not be repeated. But he has told me, sir, maximum audience are the students and few faculties members are there. So I have to balance this part. I have to give some basic idea of the robotics. Just like when you have to choose whether it will be hydraulic or electric, what are the parameters are there? What are the parameters? It has written, comes to the point. Load capacity. It will be, you have to negotiate the load. Sir, where will be the load will be placed? At the top of the moving platform. Suppose you have to move the 100 Newton loads. That is very high load. So at that time, hydraulic actuator has to be selected because hydraulic actuator can negotiate the high load compared to your pneumatic or say your electric actuator. Just like I will give one practical example in your aerodynamic system, there the actuators they are using, whether they will use the hydraulic or pneumatic or electric. Now there the load is not too much. Where the load are there. Now if you see in the aerodynamic structure, in the wings part, that aileron few parts are there, because there is just like in our cycle, in our bike or some cars, the brake is there. But in the aerodynamics, what is the brake? Now they have to create that aerodynamic term, that drag and lift force. That lift force is required to lift the total weight, and drag will be required for your braking purpose. Basically, you have to increase the drag force. So that time you have to open that aileron or few parts, spoiler, few terminologies are there. So once you have to open that part, just like the splitter AC in our home, in your college, in your some building, if you see the splitter AC, that splitter part is open. Just like in the aeroplane also, that splitter parts are there, aileron are there to increase the aerodynamic force, that drag force. So when you have to open that splitter part, you have to use that actuator. So that actuator will be hydraulic, pneumatic or electric. Now that load is not too much. Again, another point is that in the navigation system, in the aerodynamic system, if you use the hydraulic actuator, you have to carry your tank where the hydraulic oils are there. So that tank's weight is very high, and when that weight will be very high, your lifting force will be more. That means your oil consumptions will be more. So this is the parameter. That time you should not use the hydraulic. You have to use the pneumatic actuator, because within your troposphere, stratosphere level, where your aeroplane is moving, there the air is available. So air can be compressed by compressor, and that will be used to your pneumatic actuator. So these are the parameters you have to choose. Other parameters are there. You can follow up. I am giving the hints how you have to choose the hydraulic and electric and pneumatic parameters. Your actuators are there. So now comes to the structure and terminology. Few structure terminologies are there. Maybe if you do some work in future, you have the idea. I will give I have already mentioned the basic terminology. That means your moving part, fixed moving platform, fixed platform, cylinder, bottom point, top point. These are basically the vector points of view. Just go through that part. No need to concentrate too much, because this is related when you will do the experimental works. Okay. Now, so what are the different points you have to consider when you will do the some real-time work. Now at first you have to think out what are the parameters what I have mentioned here, upon which you have to take the decision whether it will be hydraulic, electric or pneumatic. Then second part, you have to do the SolidWorks modeling. Why sir SolidWorks modeling? Can I go to the directly the fabrication or real-time work? No, the answer will be completely no, because of there should not be any trial error method, because lump sum amount will be there, time will be consumed. If there are some errors will be there, your time will be wasted, your money will be wasted. So before going to your fabrication, sir, what is the fabrication term? The fabrication term basically that is the what you have to going to the manufacturing part basically. So before going to that part, you should have some modeling which can be done in different software. We have done in the SolidWorks. SolidWorks modeling means we have to give here, you have to design exactly what you are planning. That means you have to give the bottom point, top point, actual dimension, whatever you are planning basically you will giving to that particular software. If you go through that software you have some idea, or if you don't have idea you can do that work, because as a mechanical engineer, electrical engineer or any whatever the branches are there, before going to the real-time work, real-time applications, real-time any work, you should go through the SolidWorks modeling, SolidWorks simulation work. Whether any error is coming, any fumbling is there, whether any correction should be needed, if it will be required, you can do in the simulation work, where only time has been spent, but not more too much money will be done, because you are not going through the manufacturing. So this is the SolidWorks modeling basically. There the whatever the three linear and rotational motion has been done. I am going just going through that slide. This is the search motion. In the slide search motion, if you follow up 1 and 2 actuator, that means that is 1 and that is 2. This is the same extension motion. At the same time 3, 6 in the retraction in the same magnitude but in the different phase, and 4, 5 this is very small extension and retraction in case of your search motion. Similarly, if you go through the sway where the 4 and 5 in the opposite direction, 1, 3 in the coupling, 2, 6 coupling in the opposite directions are there. But in hip motion means all the in the same motion. That means in the Z direction. So if you see 1 to 6, all the actuators in the same motions are there. So similarly, your roll and pitch and your motions has been done in the SolidWorks modeling. Now comes to the mathematical part of the motion dynamic equation. Motion dynamic equation means how that particularly one piston and piston rod is moving inside of the cylinder, that has to be done with the mathematical dynamics modeling. Sir, why it will be required? Now when you have to control each and every actuator individually, you should know the dynamics of that part. Just like as a teacher, when you go to the class, you should have idea each and every student, what are the characteristics of the student, so that you can control that student. Because of once I have joined also in the first day in any college, I have the problem how to control. When 1 day, 2 days, 10 days, 1 month is over, I know how to control that X, Mr. X, Mr. Y, Mr. Z, how to control this student. Because all the students are not unique characteristic, different characteristics are there. So just like you should have the dynamics equation. This the dynamic equation has been written, not going to the details, but this is how you have to design the dynamics modeling. Whatever you will designing that things, if the dynamic motions is there, you have to dynamic mathematical equation should be designed. Okay, then comes to the kinematic. So what is the dynamics and kinematics? This is related to our mechanical point of view. Maybe the other faculties, other departmental faculties are there, but in the first year or second year basic science, we have the idea dynamics and kinematics. Dynamics related to some motions. Kinematic, that is related to where we have to know the how that in case of the dynamics when some accelerations will be there. But in case of kinematic analysis, in the your particularly that 6 degree of freedom Stewart platform or the serial manipulator, whatever the things are there, what are the displacement of that particular piston? Piston means your that piston and piston rod. What is the particular how that displacement is there? Once it will be in terms of the force, then it will be dynamics, and when it will be only the displacement, it will be the kinematics. So in the kinematics part for our that parallel manipulator, there are two parts are there kinematics. One is inverse kinematics, another the forward kinematics. What is inverse kinematics is there? Suppose third party is given the roll, search, heave, whatever the motions are there, he is giving the 15-degree roll I have to create. The question is there, to create that 15-degree roll or say 60 millimeter heave motion, how much displacement of each and every pistons, that calculation should be done by the kinematics modeling, and that mathematics is called as inverse kinematics. Okay, and that should be clear. What is the forward kinematics? Now forward kinematics is just opposite. Opposite means if you are giving the points of each and every piston motions, then you have to calculate the final motion of the moving platform. That mathematics is called as the forward kinematics. So these are the mathematical things has been required. Mathematical equation has been given. You can follow up. But I am giving the basic idea what is inverse kinematics, what are the forward kinematics. In our system, bottom point and top point coordinate has been calculated, has been taken from the SolidWorks modeling, and that has been given. If you will design, that may be some different points. That is not a very challenging part, because once you are designing, you should have the idea what should be the bottom point and top points will be there, depending on the your actuator size, depending on your bottom platform, top platform dimension. Okay, now comes to that MATLAB simulation work. What we have done previously, SolidWorks modeling. Then again, before going to your real-time work, you should have the MATLAB simulation to validate your SolidWorks modeling. Okay, so in the MATLAB simulation also, that search, sway, heave and roll PCO, each and everything has been done. It has been compared with the SolidWorks, whether it has been matching yes or no, whether 100% matching or how much percentage is matching. If it is not matching, you have to go to the SolidWorks modeling or mathematical modeling where the errors are there, you have to rectify, because of to get the accurate result from your manufacturing part. Because if any error in the manufacturing, that is very hard to recover this part. So your simulation work, that means your SolidWorks, MATLAB, both work should be done before going to the manufacturing. So these are the few combined motions has been given. Now comes to the real-time experimental work of that particular platform. Okay, so this is the with the hydraulic actuators. This is the real-time platform. These are the all actuators. This is the moving platform. This is bottom platform, and one zoom view of the one actuator. This is your proportional valve basically, which will controls the motion of each and every pistons motion. And this is the your PC, from where you will control your motion, required motion of the each and every piston. This is the real-time system. This is the output module. This is the input module. Input module basically receives the feedback of each and every pistons, how much it is moving. Output module basically it will gives the signal to the your pistons actuators in the proportional valve, how much motions should be done for the each and every pistons. So this is the total real-time experimental setup of the hydraulic with the hydraulic actuator. This is the controller design. What I have told you, what is the requirement of the dynamic modeling or some to design some controller. Controller means which will control your required motion basically. Suppose you are giving say 15-degree roll, it will be calculated by inverse kinematics modeling how much required position of the each and every pistons, that is called as LD. Now you are sensing with the LVDT. LVDT means linear variable differential transducer. So with that you are measuring the actual motion of each and every piston and you are comparing whether it is close to your desired motion. If there is some error, you should rectify. No? So how you can rectify? The question has come. That question can be solved by the controller. Controller basically, just like in your college also, exam controller is there. Exam controller activity, say to control the exam process very smoothly without hampering the normal activity or without any failure of the registration of the any students or without uploading any numbers of the students. This is the purpose of the controller basically. In case of our real-time experiment also, that controller activity to rectify that error. So this is the purpose of the controller. You can design different type of controller. One very simple controller has been given here, PI, that is the proportional and integral controller. There may be different controller, fuzzy controller, sliding mode controller, another different modern controllers are coming. I'm not going through that part. So this is the controller, it has to be designed to get the precise motion. That controller will produce the required command signal that will go to the proportional valve and that will control whether it will be required positive voltage, negative voltage, or any type of command will go to that your proportional valve, what we have in our figure. Again, it will come to the LVDT. That process will be in a loop basically. So this is the PI controller design part. Then your real-time experimental with the some single actuator, 6 actuators, few videos are there. I'll show you after completing this part because it will take some time. So I'm not just disturbing here. Now comes to some few experimental results. If you see, this is for the surge motion. Few experimental works has come, and this is the sway. This is the hip motion. In hip motion, if you see, all the 6 actuators are in the same motion, but in case of your surge or sway, some coupling motions or different actuators. Okay, so similarly roll, pitch, yaw, these are the experimental works. So that's why I'm not going through, because of if you in future, if you the students particularly, if you go to any research work, then you have to go through that part. Okay, now comes to that real-time motion of electric Stuart platform. Basically that work has been done by Mr. Mintu Ghosh, who is the assistant professor in your college. He has developed that part and he is doing his research work in the PhD under my supervision in my college. That establishment has been done. So these actuators are the electric actuator that has been replaced. That initially it was hydraulic actuator, then it has come the electric actuator. Why? Cost is less. When you purchase the hydraulic actuator, that cost is very high. But load negotiation is high in case of that part. But here the load negotiation is less. Most probably that 200 Newton of each actuator can be done. So if the moving platform, there is the 1000 Newton or 1200 Newton load, it can negotiate near about. The host PC, which can control the what I have told initially. Here, Arduino Mega board has been used, and your each and every piston, once it has to be controlled, the motor driver that we are using here L298N, and another is the voltage supply. That means 24 voltage supply has to be done to the each and every actuator, and 5 voltage will be required for the Arduino mega board, and also your motor control card also can be required. So that's why one power supply has been used. So here our main purpose, main motto, main challenging part was there to get the feedback, because here the feedback mechanism was by Hall effect sensor, which will gives 0 or 1. That 0 1 pulse counting, we have to take how much millimeter of the displacement of the pistons are there. That was very challenging, and that work has done most probably 6 months to most probably 1 year. Mintu has done that research on how to get that value, because it was very challenging work and hard work was there, because there is no previously, we don't have any idea. We have to basically trial error, then again, then we have find out finally one result. Within this much pulse counting, that millimeter movement of the pistons are there. Now comes to that few real-time application he has developed. I have taken that figures from him. Thanks to Mr. Mintu Ghosh for developing that type of things and doing that works. What are the applications we are trying? Few applications have been given. There is the moving part. No? Then if we, here basically the arrangement is there, one wax container. Wax is molten and it is put inside a wax container. There is one nozzle. By opening the nozzle, molten wax is coming from that point to the hair. Suppose you have to design, you have to make one slot just like this part, 40-degree angle, and that radius is 0.08 meter. So if you do the yaw motion minus 20 degree to plus 20 degree, and that amplitude is 0.08 meter, motion of your moving platform, your wax container is fixed, your moving platform is moving. By that, you can make that type of slot. What is the advantage? Now, when you have to make that type of slot in manually, there will be some problem will be there. So by moving that yaw motion, we can make that type of slot. So in other difference can be done. I hope I have, okay. The other application already we have done, but it is not given here because it is under the some publication process are there. So maybe say surge motion, some heap motion can be there. If some surge or heap motion, if you put some say tools, you can do the slot cutting. So you can see the job is there. If the tool is placing, if the motion of the moving platform of that particular platform, that slot will be cutting along the Z axis, along X axis. That means heap motion, surge motion, with the required your slot that width, you can perform this type of work. So these are the different applications has been done. Few already communicated for the repeated journal. I hope that comments has come and he has communicated this part. Some major revision, minor revisions are there. Maybe it can we have some acceptance within few months, and few papers are undergoing. I hope we can publish few another papers also, and maybe we can try for some patent also, because that cost of manufacturing of this type of platform is very less. Within the 2 lakhs, it can be done, where the hydraulic platform that is most probably say 40 to 50 lakhs will be required. But maybe that the load negotiation is high, but that type of work is not required for the high load. Now that precision is required. So this type of work can be done with our developed platform. So we can carry forward for the patent work or some research work also. Now, what he mainly that Mintu has developed, that some feedback controller with combining me also, that fuzzy tune feedback controller. Fuzzy tune means fuzzy controllers are there. Fuzzy logic. It will give the decision what will be the value of your proportional and I. That means PI controller part. There is one is P, one is I. So what is the value of P and I? Who will decide? Whether manually or it will be online process when it will be doing the your operation has been done. Depends on the error. The fuzzy logic, that means your fuzzifier, defuzzifier, some KPKI matrix depends on your, if high error is there, high value of the KP. If less, just like in our mind also, if my salary is high, my expense will be very high. That is the logic is behind of expensing my things. No? So similar way that fuzzy logic is given. Different that GA also genetic algorithm that also he has developed, and artificial neural network based PI controller, GA based that feedback controller. Recently, I hope he is doing the one modern controller that we are going to design, sliding mode controller. I hope we are getting the very satisfactory result compared to the PI, because sliding mode controller, that is related to the system design, that will be related particularly concentrate on that particular system. But in the PI, what I have told, this is not the system dependent. So what he has get, what already he has got the result. I have given here few results with the PI and fuzzy PI. If you compare that PI and fuzzy tune PI or fuzzy tune feedback controller, some control parameter, integral absolute error, control effort, say your variance, standard variance, say your error, whatever different control parameters. I hope he has given here IAC. There are another control parameters also he has already got the result, but maybe it is not given here. Why you have to given there? Because you have to choose which controller is suitable for that particular operation. Then you will do the operation for the each and every type of application. So this is the, you have to choose the controller. If you see the figure, PI and fuzzy PI, in case of PI, very noticeable things are there. Here is one chattering, that means up and down. That if you see the chattering of the moving platform, that means some vibration is there. In case of fuzzy PI, there is no chattering. You can give the ensure because of here the error is less. In case of PI, nobody is there to decide the value of KP and KI depends on the error. But in case of fuzzy PI, fuzzy logic is there. When the error is less, your value of the P and I will be less. That's why there is no error there is no vibration, there is no chattering. So this is very smooth operations are there. So this is the noticeable figure I have mentioned here. Now comes to some videos with the electric Stuart platform. Just you see that video is visible, Mintu?
Yes, sir, it is visible.
Okay. So this is the electric neutral to 80 millimeter. It has written. Neutral means total motion of the electric actuator. What we have taken, that is 0 to 150 millimeter. So neutral position mid span of the each and every piston. That means 75 millimeter motion of. This is the neutral position has been called in our case. So neutral to 80 millimeter. 80 millimeter means not the electric pistons, that is the 80 millimeter of the your moving platform motion. So for the 80 millimeter motion, how much motion of the each and every piston, that will be calculated by inverse kinematics. So that is the requirement of the inverse kinematic. So this is the basically heap motion what I have shown here, the neutral to 80 millimeter. Now again you see that will be going from neutral to 80 millimeter. All the pistons are moving in the with the same magnitude and moving platform moving 80 millimeter direction. This is the roll motion. If you see here, okay, just you see the roll motion. That means along the x-axis, the roll motions are there. Say most well this this is the 15-degree roll motions are there. The application is, suppose some materials are there, you have to replace that materials, you have to move some materials 15-degree, you can move that with that platform. And this is the surge motion. If you see along the x-axis, this that motion is done along the x-axis. This is the surge motion, 80mm surge motion. Yes. And this is your okay. This is the yaw motion. Yaw motion means along the z axis the rotational motion is there. Yeah, this is very typical type of motion. Really, I share my feelings before going to that type of motion. I was confused also. If that yaw motion will be there, is there any breakage to the different joints? Really, I have done the simulation works in the SolidWorks, MATLAB, but when it is done initially with the hydraulic actuator, I have confused. But as that design was very fine, there is no breakage it has done, because it is just like a twisting type of motion. That is the yaw motion it has done. Okay. Now this is the some experimental result has been depicted in this figure, the surge motion. This is the that if you see that surge motion has done with the rise time 6 seconds, because if that distance, this velocity most probably that is 150 millimeter motion can be done within how much time into that motion?
17 seconds.
17 seconds. So if you calculate that will be somehow it will be less, because of some frictions are there within that piston rod, some joints are there, so this is the some loss of the current, some voltage. That's why that rise time or your settling time, what it has mentioned, that is somehow it is less than that given velocity of the each and every pistons. And this is the yaw motion results. These are the publications. Before going to the publication, what I have told you that I'll show the figure with some hydraulic motion. Just I'm trying just whether it will be working, yes or no, because most probably it will be working. Just wait. It will take a few minutes. Just wait. Yeah, if you see, this is the hydraulic single actuator. Then the loads are springs, high compressive loads are there, and it is moving with the sinusoidal motion. This is the hydraulic actuator basically. There is one port that is coming from the pump. This is going to the tank port. This is the load is given, and this part is the LVDT basically. LVDT, it measures the actual actual displacement of the piston, and this is the PC, where it will be taking the actual position to the your input module, output module, and this is the results. If you see, the white color is the demand and red color is the actual position. Maybe there are some noise, so there are some peak and ups motions you can have that real-time results. So this is the why I am showing here. This is the real-time experimental point of view. This is the your we have done this is with the lab view basically. With the lab view software, we are taking each and every moments. What is the actual position? This is the sinusoidal motion has been done. Okay. Another videos also there, but one important figure I am going to show you. With that Stuart platform or 6 degree of motion, my supervisor was there. Two supervisor was there basically, Professor Dipankar Sannal and Professor Rana Saha. Professor Rana Saha is sitting on that Stuart platform. I have requested, sir, please sit on the Stuart platform. I have designed one chair, and chair was placed on that platform, and Professor Rana Saha was sitting there, and I have given that all the demands simultaneously. That means your hips, hearts, sway, and roll PCO, all the motions has been given, and he has that feelings. Just one minute. I hope that video is proper. I think that aspect ratio has changed. That's why it has been distracted to that. Actually, that figure has been distracted. Anyhow, if you see, that is the search motion is done, and that person is sitting, Professor Rana Saha actually sitting there. This is the, if you see, this is the sinusoidal type of hip motion is there. And this is the roll motion basically. Along the x-axis, the rotational motion is done. And this is the pitch motion. And this is the yaw motion. If you see the twisting type of motion, what I have told you. Okay. So another videos are there. I'm not going through because the time mostly it is coming to end. So now go to the that part where I have clicked. So these are the application. These are the few, the publications what I have done. Depending on that, my research work basically on that electrohydraulic, pneumatic, and electric actuator, that robotic application control, and design the modern control for that particular type of Stuart platform, parallel manipulator, or some serial manipulator with the hydraulic and pneumatic and electric actuator. With that few applications, that few journals, it has been done, and few book chapters, and some students are there, master degree, also the PhD students. He also the professor in your college, assistant professor Mintu Ghosh. He's doing that work, the development and control of a low cost. The challenging part is to design the low cost 6 degree of freedom, because initially what I have worked in the hydraulic actuator, that cost is very high. But in my college, when I have shifted to that college after doing my research work, that much amount cannot be possible to do that work. But I cannot stop the work. So I have thinking how it can be done with the low cost. So that's why I have, that necessity is the key of invention. So once the necessity was there, I have to think out how that hydraulic actuator can be replaced, and the electric actuator, I have to think. Then lots of challenges was there because of the particularly the feedback point of view, to getting the data, to getting the people. Finally, we have developed, and the research work, what I have told you, fluid power control, mechatronics, that optimization technique, that GA prediction technique, that means the soft computing, better to say, developing the modern controller, sliding mode controller, and few logic, that fuzzy logic, and finally that platform related, that motion control, that means your mathematical modeling, that SolidWorks, MATLAB design, real-time work, that then to design the controller. So these are the few research area. This is my contact, myself basically. Already Mintu has told, Sipsanko Dasmavatra, I am the professor of the mechanical engineering department. and this is the my contact number and mail ID. So if any question, any query, any suggestion also from your side, from the participants, you can share with me. Or if you have any further research interested, any say from BTech or any other scholar or maybe some PhD related work, you can contact with me, because really that we are the academician, that so that we should have some engagement with the research work also, so that we can enhance our teaching capability. So thank you again to all the participants, particularly to the organizing committee of that particular STTP program, and special thanks to my students, Mr. Mintu Ghosh, to call me particularly on that particular program. Thank you.
Thank you very much, sir, for this wonderful session. Your example-oriented explanation have definitely helped our students to understand in an easier way. We are truly privileged to have benefited from your wisdom and knowledge in the real-time work, and we are also thankful for giving us your valuable time for the benefit of our students from Bengal College of Engineering and Technology, Durgapur. Now, the session is open to the participant. So, if you have any query, you feel free to clear your query from Dr. Dasma Patta. So, anybody, if you are having any query, please place. If anybody having queries, please.
No, sir.
Okay. Okay, sir. Then again, once again, I thank you for this session.
Okay. Okay.
I thank all
Okay,
the
me.
participants for your patient sharing during the session. I think you have enjoyed the session also. So your next technical session is at 3 p.m. on recent advances in high energy physics by Dr. Sukhdev Sao from NIT Durgapur. So please try to join 15 minutes before 3 p.m. So thank you all. Have a wonderful day.
Thank you, sir.
Thank